Hey everyone, we are looking at page 30. If you're looking at fundamental applied maths, question 6. It's got that blue line beside it. It means you're looking at a higher level question. This question says a car moving with constant acceleration that you need to work out passes three posts A, B, and C on a straight road. The distance from A to B is 48 meters, and from B to C is 102 meters. The car takes 4 seconds to go from A to B and 6 seconds to go from B to C. Uh, find the acceleration of the car. Now, this type of question comes up a lot in 2C. You'll see it come up quite a lot in this exercise, where you've got these multiple posts. And what you need to do is you need to generate two simultaneous equations and two unknowns, which is a very common trick in applied maths. And then you solve the simultaneous equations to get your answer. The trick with this one, and you need to learn this, it's not by heart, is both of them need to start from point A. So you'd be tempted to come up with two distance equations, one with 48 in it and the other one with 102 in it. That's not the correct way to do it. The correct way to do it is one with 48 and the other one with 150 meters in it. Okay, so let's have a look. So as you go from A to B, you don't know what your initial speed is, but you can just call it U. Okay, because what's nice about it is the same initial speed as you go from A to C. Okay, and this is what makes this approach of starting from point A nice, is that you've got the same variable top and bottom, your initial speed at A. Final speed, we're not going to worry too much about. Acceleration is the variable we are interested in here, and in both cases, it's whatever this constant acceleration is that we're trying to find. From A to B, the distance you have traveled is 48. And from A to C, the distance you have traveled is 150 meters. The time that takes is 4 seconds to go from A to B and 10 seconds to go from A to C. Okay, so once you have this set up like this, it's not too hard. You're going to use S equals UT plus a half AT squared. So you're avoiding V. And you're going to do that twice, once here and once here, to get two equations and two unknowns. Give that a go yourself. Just pause the video and try it. Okay, hopefully what you've done is S equals UT plus a half of AT squared, and that gives you 48 plus 4U plus 8A. You might have spotted a common factor of 4 there and divided through by 4 just to tidy that up, and that's quite a useful thing to do, and we'll do it quite a lot. So you get 12 equals U plus 2A. From A to C, you said distance 150, initial speed you don't know, time is 10, plus a half times the acceleration you don't know, time is 10. Again, 150 is 10U plus 50A squared, a half of 100 is 50. Dividing through by that common factor of 10 gets you 15 equals U plus 5A. So these are our two equations. Solve them simultaneously and you can work out the value for A. Okay, so here they are rewritten. If you subtract that lower equation from the upper one, 15 take away 12 gives 3, U take away U is 0, and 5A take away 2A is 3A. But if 3A is the same as 3, then A is 1, and its acceleration, so 1 meter per second squared, is the acceleration of the car. Okay. The next question we'll look at here is question 11 on page 31. This one says a train starting from rest at P accelerates uniformly for 10 seconds, travels at a uniform speed for 32 and decelerates for 6 seconds to rest at Q. Draw a velocity time graph and then find if the distance is 1 kilometer, find the maximum speed reached and the distance traveled during each part of the journey. Okay, they haven't told us what the uniform speed is, so all we know is we reached that speed in the first 10 seconds. So we accelerate up until some initial speed in the first 10 seconds. Then for 32 seconds, we travel in a straight line. So that brings us up here to 42. We travel at a constant speed, sorry, not in, well, and in a straight line. So that's our speed doesn't change. And then for the last 6 seconds, from 42 to 48, we're decelerating. Okay, and it only asks for a rough time, velocity time graph. So there it is there. Okay, and as I've said before, if you can fill in any information here, you will. Let's see, I don't think we can straight away, so we'll come back to it in a second. The question says the distance from P to Q from start to finish is 1 kilometer or 1,000 meters. That's the total distance. Find the maximum speed reached and the distance traveled during each part of the journey. Okay, so the maximum speed reached, find v. How do we do that? Well, we say, I don't know the total distance, and each of these is 3 separate sections. Sorry, I do know the total distance though. Okay, S1 is this distance, S2 is this one, and S3 is this one. If I want to work them out in terms of v, I can get an equation just with v in it as one variable and solve it. So S1, that's a triangle. So the distance is half the base, which is 10, multiplied by the perpendicular height is v. S2, that's a rectangle. The distance is the base, which is 32 seconds, multiplied by the perpendicular height is v. And S3 is a triangle. Half the base was 6 seconds, multiplied by the perpendicular height, v. And I know if I add them all together, I'm going to get 1,000 meters. Okay? So tidying that up, you get 5v plus 32v plus 3v, which all adds up to 40v equals 1,000. V is then 1,000 divided by 40, which is 25 meters per second. So there's our final speed. The question also asked the distance traveled during each part of the journey. So you have to come back to here, a half of 10 times 25. So S1 is a half of 10 by 25. That's 125 meters. S2 is 32 multiplied by 25, which I'll come back to in a second. And S3 is a half of 6 times 25, which is 75 meters. So calculator work on that will tell you it's 800 meters. Okay, so those are our 3 distances. Okay, I'm going to ask you guys to try question 7, which is very similar to question 6 that we've just seen. And I'll see you in class.